So we have a MacBook Air. It says no backlight. The back screw is already out. The battery is disconnected. Let's connect the battery, start it, and see what we have. Doesn't seem like the battery is charged. Let's use a charger. Okay, starting. Mm. We didn't have anything on the screen.
This one left because there was one was showing a logo, and the other one has windows inside.
Okay, let's
So
try
use
to
the
do
flashlight from the back.
let's try to do a PRAM reset then. I'm not sure if you guys can see that, but I can see it. Can you see that?
Yeah, it's not so clear, but it's
Like this?
yeah, and like two partitions showing.
Yeah, like this. So we have the one that says Sierra. They're actually both Sierra Sierra. Uh, you can see that, yeah? Okay. Okay, so no backlight. What we want to do is that we want to see what we have on our backlight output. Okay, seem to have corrosion that section of the board. The board, its board number, it's an 80-00165. This is a 20. Because of the JTAG, we can confirm that this is either 2015 or 2017. Let us also open up J8300. Let's see, J8300, J8300. Um, that's the screen connector. So at the screen connector, we will have the PPHV underscore SO switch underscore LCD backlight. So that is going to be, so here, that's going to be pin 3 and 4. Now, two things we will worry about when you're dealing with a backlight issue. First thing you want to do is you want to confirm that your screen is being detected. So to confirm that the screen is being detected, we can actually see image on the screen. I'm not sure if you guys can see that. Let's see. Can you see that? Our screen is okay. I'll just try to switch it on again. Taking forever. Okay, let's disconnect the battery. Start it with a charger. Okay. Okay, that's it. So we've got an Apple logo. That is that we can confirm that definitely the screen is being detected, because you need to have a screen being recognized, a screen being detected before you can worry about the backlight section of the board. If you don't have image, don't worry about backlight. First, you need image before you worry about backlight. We can confirm that indeed we have a screen. Our screen is being detected. The next thing we want to do is we want to confirm what we have. Yes, we can see that we have liquid at this section of the board. So let us see if we have a short. Let's try to remove the screen connector. Screen cable is fine, screen connector looks okay. But this cap here, which is on the backlight output line, those caps do not look okay. That. And also this cap here, and also the VL for backlight feedback, which is going to be here to our pin 5, that is also looking not okay. So first thing we want to do is let's see if we have a short on our backlight output. Okay, so another thing is since we definitely need to take the board out, let's just go ahead and take the board out. And then we can measure, check for short, and then yeah, we can do the repair after the board is out.
And also the way I see it, the backlight is not completely not bright.
Why?
It's not like GMT.
Why you say that?
Apple logo is at least, I mean, for some of the backlights I saw, some of them you can hardly see it on.
No, it's depending on the screen design. If it's a retina screen, it's difficult to see. Non-retina, it's easy to see. With retinas, it's almost impossible to spot with the retina screens. So depending on the screen, that will. Okay, board is out. Let's put a screw on the fan. Let's just put something on the fan to hold it. Okay, let's check the other side of the board. Uh, okay, so the backlight chip itself is corroded, and then we also have issue here. Let's see, do we have a short on our backlight output that we can confirm? Um, yeah, let's confirm that at C8317, which is this component here, black roof on ground. See, we don't have a short. Okay, we don't have a short. However, these components are not looking okay, and also our backlight driver, it's also not looking okay. Then backlight enable signal. You see, that's the section of our backlight driver U7701. We also have R7733. R7733 is going to be PP pin 1 of it is going to be PPV in. That is where the voltage that comes from PPV in SOS LCD backlight EN, that's going to come in, and then on the other side of the resistor you get backlight enable. So if you don't have voltage here, you will not have backlight enable signal. If you don't have backlight enable signal, there will be no boosting taking place by your E7701. So the fact that our backlight chip do not look okay, and then we also have let's so what we need to do now is I'm going to remove the backlight chip, and then I'm going to remove this component. Before I do anything, we're also going to replace R7731, but then we also need to see if we have if the feedback pin is still fine, which is pin 5 all the way to the other side. So we will also see if we still have continuity between pin 5 and our line on the other side of the board. So let's first take out these components, the caps on this side. And also we'll be removing the inductor L7701 just so we get a better room to measure our pin 5. In case the pin 5 is not present, then we'll have to trace it. Okay, so that's and then we need to also remove our 7701 as well as R7733. Okay, let's see. The backlight driver is not that bad. We can actually reuse it. Uh, yeah, we can reuse it. So remove this. The caps, one of the caps seem fine, but it's a possibility of it failing in the future. Okay, now on the other side. Okay, so the next thing we want to do is we want to see if we have continuity between our pin 5. So pin 5 and this section of the board. So let's see if we have continuity. We can check that on pin 2 of D7701. That's here. Or we can also place our multimeter probe outside. Just remove the fan for now. So we'll do this. Okay, the feedback pin is broken. Uh, the next thing we want to do, let's see if this veer here, this small veer, let's see if that is still present. With the feedback line broken, the the backlight will not boost, obviously, because there will be no boosting taking place because the chip is not aware of. It's almost like the chip is blind without its feedback pin. So let's see if we can get that. Okay, let's try to run a wire there. Let's try to add a pad where it's MacBook Air. Okay. I need to go pray. I'll be back. Okay, we are back from prayers. Let's continue with our repair. So we are concerned with the pin 5, which is the backlight feedback for U7701. Our concern is that the veer to the other side might have been severed. So, which will mean that even if we replace all of the components that have been affected by liquid without having to complete that line, making its way to the other side, then definitely we will not have a backlight because the chip will not have feedback of what is happening. So obviously, in that state, the functions of the chip will not be realized because uh, there's no feedback pin. Take a feedback pin more like the driver driving without having eyes on the road. So basically, the driver will obviously want to stop. So let's just confirm that we have. Let's see what we have on that. Let's just see. So basically, we're trying to confirm that we have a communication between pin 5 and C77, the line of C7797, D7701, basically. So X, and then another thing I was going to mention is, okay, just a quick one. Let's see what we have. Let's see. So basically trying to compare, that's OL, basically trying to compare the readings of a known working board to that of so definitely we have a broken link. The part from the other side of the board, it's broken. So what we now need to do is we need to put a tiny solder ball. And by the way, XW 7720, that if we see that the pin out, the test pad, we see that the test pad which is connected to pin 1 of XW7720, that is broken. Now pin 1 of XW7720 and pin 2 will be the same thing. So if if the test pad is connected to pin 1, what that means is the test pad is also going to be connected to pin 2, which is where it makes its way to the backlight output line. So what we want to do now is we'll scrape just a little bit and then put a solder to basically connect our test pad to the line that's been broken off. Because if we don't do that, even if we replace all of the components that seem to be messy on the line, the backlight is still not going to work. So let's just see if we know. Let's now. So what we want to do now is we want to confirm continuity on pin 5 of U7701 and the other side of the board. Okay, that's fine. That seems to be working. The next thing we want to do is want to put back the components. We basically get these components from another board and then we can replace them. We have confirmed that the line is fine. So what we basically had to do was to put a solder bulb there. So the next thing we now want to do is to put back all of the components that were corroded. We'll take them from a donor board. And I did stress the importance of having a donor board. Imagine if you don't have. Yeah. Imagine if you don't have a donor board. You obviously imagine if you have to order all of these components individually. That would really delay the repair. Okay, so now let's put back the components. Basically, we will putting back the capacitors, the diode, and the inductor. We also have to be careful because we did put a solder bulb at the text pad of our PPV out, SWS LCD backlight feedback line, as well as the PPHV underscore SOS SOSW underscore LCD backlight. So let's just put back our component and then try to reflow them in place. And then afterwards, we'll now have to we'll try to reuse the backlight driver, even though we did find a bit of corrosion underneath it. We'll still try to reuse it. If it doesn't work, fine and good, we will just replace it. But we'll clean it up and try to reuse it and see if that will work. Okay, that's seem to be it's in its place. Just a bit of a further reflow in that area, and then we'll try to be careful not to melt out our solder bulb that we put in place. We didn't use a wire because it was close, so we just had to put um, a solder there. So now that it's done, the next thing we want to do is clean out U7701, the one that we had taken out there before. Let's just confirm what we have now. Let's see what we have. Let's try again just to make sure that we have continuity on both sides of the board. Do we have continuity? Yes, we do have continuity. That's good. So next thing is to let's just confirm just to be sure. Yes, we do have continuity. That's good. Okay. So the next thing we want to do now is to clean our backlight chip, which is U7701, and try to reuse it. Yes, we understand that it may not work, but yeah, it's we can try. So we clean it and then try to reuse it. And then, by the way, understand that U7701 does have orientation. So the pin 1 of U7701. So when you are replacing when you're replacing the backlight driver, be very much aware of the orientation. So pin 1 is going to be at the top of it. So let's put that back and then see if it's going to work. Orientation is very important. Make sure it's properly oriented. Okay. And also we also need to replace because R7731 was also affected. That also needs to be replaced. Yeah, so R7731, we also need to replace that. Just grab that from a donor board and replace it. That's where our enable signal is going to come from. So PPV in SOS LCD backlight it will come through R7731. The two resistors there, those are set of voltage dividers. So they will then slice our voltage from 8.6 volt up until 2 point something volt for the backlight enable signal. It's just that has been put in place. The next thing we want to do is see if we have a working backlight. We will obviously uh basically we're not 100% sure that the backlight driver is going to work, but we will just try it out. It doesn't work, then we put in another one. Give it a bit of time to cool off. uh and then so grab a test screen just to see what we have. So the test screen that we have, it's broken, but for the purpose of backlight testing we can use it to test our backlight. So we so usually because it's broken, when I don't have when there is image on the screen, just I just get a bunch of lines reaction on the screen, which you have to look really close before you can see. So I'm because I know definitely that this is not I'm not looking for image. What I'm looking for is backlight, and for the purpose of backlight testing, I'm able to use the screen. So I'm not really worried about the state of the screen. What I just want to see is to see if I have backlight on the screen. So let's test and then see what we have. Do we have backlight or not? Just wait for it. Okay, we have found spin. Sorry, the drive moved from its place. We had to quickly disconnect it. Okay, let's try again. Or okay, we have found spin. Do we have backlight? Do we have backlight? Do we have backlight? Mm, 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 mm. We don't have backlight. Now, okay. Uh, Now we don't have backlight, but we do have. We can see lines on the screen, which indicates that this is basically there is display, but there's no backlight. Let us see what we have on our backlight output. Will most likely not boosting. 8 point. Let's see. 8.5. Let's see there. 8.5. Okay, we're not boosting. Okay, we have to still go back to the backlight circuitry to see what we have. Let's go back to the backlight circuitry to see what we have. And so I would like to put a screw to hold the fan in place so that it doesn't stay loosed. Okay, let's go back to the area of E7701. Let's because as far as you're concerned, the other side of the board it's fine, but the area of E7701, and especially because the E7 the backlight driver that we used, we are not 100% sure of it. So most likely we will have to put in another one. So let's just check. Just make a bit some measurement and see if we are still good. Yeah, that's fine. The feedback line is still okay. Yeah, it's just we're trying to compare that from a non-working board. Our feedback line is still fine. Mm, just that has nothing to do with our issue. I'm just making sure that the cap is properly straightened up. It has nothing to do with the issue that we're having. Okay, now we have to head back to the area of E7701. So let's try to redo it again. Check underneath it just to be sure that we don't have any missing ball, and then see and then again and try it again. If it doesn't work, then we will just have to replace it. So if it doesn't work, then we'll just have to replace it. And then another thing we will have um to check again, it's because we did replace R7731. The backlight enabled signal, we didn't check that. We'll have to check that. It's just give it a moment to cool off, and then we will definitely have to check our backlight enabled signal because we didn't do that. We yeah, that we need to check. Let's give it a moment to cool off, and then we will check to see if we now have backlight. Uh, and like I said, we're not 100% sure if the backlight can still be reused because of liquid in that section of the board. But nonetheless, let's just see. If it doesn't work, then we have to put in another one. Let's try again. Let's see what we have. And this time we will definitely need to check for our backlight enable signal. You guys may not see the Apple logo because the screen is broken, but I am able to see lines, which is a reaction on the screen to tell me that now I have display. But obviously, yeah, those are lines. So, but there's no backlight still. Let us see what we have on. Let's see what we have on our backlight output still. Do we have 8.5 H6 ish? Yeah, we still have 8.5. So basically that we still don't have boosting. So let us see what we have on our backlight enable signal. Because remember I said we did replace R7731. Oh yeah, okay. We okay. This we actually okay, so what happened was R7715 moved from its place. So, which would mean that there's no voltage division taking place. So instead of 2 point, yeah, yeah. Okay, so we're getting 8 point something volt instead of 2 point something volt for the voltage enabled signal. Yeah, okay, that's a problem. So definitely what's happening is that this may be like a two-in-one issue because instead of instead of the enable signal to be around about 2.8 volt, I don't know about that, 2.6878, 2.8 volt ish, we are getting 8.5, which is exactly what we're getting at the ppv in on pin 1 of R7731. So which means there is no voltage division taking place. So that's definitely the problem. For my backlight, I need to have an enable signal of 2 point something volt. Okay, so we may have two problem in one. So we knocked off R77 15 when we were replacing our E7701, which is the backlight driver. So what we want to do now is we want to put that back, and then yeah, let's put that back. so we can basically test again and see what's happening. So we need our backlight enable signal should be 2 point something volt, not 8.5, 8.6 volt. No, definitely not. So let's put back that resistor, and then afterwards I'm just going to show you guys how that works. So if we go to our voltage divide, let's just basically go to our voltage division. I'll show you guys now, and then so you guys will have an idea of what value we are expecting to have. So at the enable signal, there you see the enable the BKL underscore EN. So that is the enable signal. Now that goes through a series of voltage dividers, a series of resistors that will do the voltage division. So basically, they turn a high voltage into a low one. So we have one resistor tied. You have a one resistor pin, one resistor tied to the input of the voltage. The pin 2 of the resistor will be tied to another resistor, which would then be tied to ground. So that is how the voltage division will take place. And if one of the resistor it's basically not doing its job, in this case, not being connected to ground, what will happen is the voltage you have on pin 1 of the resistor will be exactly the same thing you have at the output of the resistor without any form of reduction taking place. So let me show you guys basically how that can easily be calculated, so you guys will have an idea of what we are talking about. So let's just take a minute. The internet is quite slow. Let's see. So under your voltage divider calculator, it's just calculated so that I'll give you guys an idea. And yeah, sorry guys, the internet is slow, I know. Okay, so here what we have, so let's go to the input voltage. What is the input voltage? Input voltage is about 8.5, 8.6. So let's see, our input voltage is 8.5, 8.6. And then what is now, we then have to divide that by basically, let's check the value of both resistors. One of them it's 200 kilohms, and then the other one is going to be 100 kilohms. So now the output will vary according to the value of the resistors. So when we calculate, let's click on calculate, and then what we see that we're supposed to get 2.8. We're supposed to get 2.8 volt, not 8 point. So we are supposed to get 2.8 volt and not 8.5 volt. So definitely that it's a problem. So we may just be having two problems in one. So which is our enable signal was not present, as well as we may also be having a faulty chip. So now let's see, do we have 2.8 volt as expected after putting back R7715? Let's see, what do we have? What do we have? Okay, that's the input voltage. And then what about our enable signal on the other side? Okay, yeah, that's it. So that's exactly what you're supposed to have, which is a 2.8. That's good. That's good. So, but now we still don't have backlight. So which means we definitely need to replace our U7701. So let's grab a donor board, replace it, and then see what we get. Okay, so now what we need to do is we need to obviously get another E7701, because definitely we have met all of the working conditions. We don't have a short on the line. We have a 2.8 volt on our backlight enable signal, but still we do not have backlight. So all of the possible issues has been resolved. The only thing that's left now is for us to get another backlight driver. Initially we were getting a 8.5, 8.6 volt on our backlight enable signal line. That's definitely not good. We're supposed to have less, and that mistake we made while we were replacing U7701. So we we accidentally knocked off R7715, and it was not basically making its way to its part. So what you now want to now that has been resolved, and I basically showed you guys how the calculations is done. So the next thing we want to do now is we want to basically get another backlight IC to basically use in place of that, because definitely our backlight IC needs to be replaced. I mean, that's the only thing that is left on the line that has not been addressed. We were just taking our chances on the backlight chip, because we did see that the chip itself had a bit of a corrosion underneath it. We tried to clean it, tried to reuse it, but that it's obviously that didn't work. So let's just grab another one, and then see what happens. Yeah, that looks good. Okay, now let's see. Let's put in another one and see what we get. By the way, this is not like a straightforward liquid damage component replacement type of repair. I mean, because you see all of, especially on the feedback pin, it's important that yeah, you take care of the feedback pin, which is on pin 5. Otherwise, you will basically do everything and you still have no backlight. You just be stuck on 8.5, 8.6 volt, which is suggestive of no boosting taking place. Just give it a bit of time to cool off, and then what we do is let's test and see what we have. At this point, we are pretty confident that that we should have backlight now. I mean, everything else has been taken care of. So the only section, or the only thing that we are now we basically yet to really uh ascertain its U7701, which we basically we hoping that the one that we grabbed now it's working. But if not, we can just grab a non-working U7701. So the one that we're taking out from an 11 inches board, we are not quite sure of it. But yeah, let's see. If it doesn't work, we just put in another one. So there's no big deal. Let's just see if it works. So let's connect our charger, and our fan spin. Do we have backlight? Yeah, yes, we have backlight. Okay, so yeah, that's it, guys. We have backlight. That's a beautiful backlight. Okay, so the next thing we want to do is just so that you guys see that we actually we actually do have a backlight. I mean, you guys saw that before. That before now, we didn't have the screen was dark. So, but now we have backlight. So what I'm gonna do is I'm gonna actually get the client screen to to see that yes, we do have Apple logo, and then we will do like a quick summary of what we or what we did, so that yeah, just do like a quick summary of exactly what we did and how we arrived at where we're at, and yeah, and then officially this is a completed repair. Obviously, we still need to do all of the clean of the board, and then Peter will obviously then take over from there. So first and first, let's basically let's test it on the client's board and see what we get. Test on the client's board and then see what we get. Pretty sure backlight is fine now, but I just want you guys to see a beautiful Apple logo. Give you guys a beautiful Apple logo. Do I have fan spin? Okay, we have fan spin. Now let's wait for beautiful Apple logo to come up. Waiting, patiently waiting for that beautiful. Yeah, that is it, guys. That's the beautiful Apple logo. Isn't that beautiful? Okay, so it's yeah, the next thing we want to do, it's basically like I said, I'm just gonna do like a quick summary. Uh of what we did and where we at, as you guys. So this was a liquid damage board, and the components by the backlight circuitry were affected, which is more on the section of the screen connector. So that is J8300. So what was affected basically, C8317 was affected, C7719 was affected, C7797 was affected, D7701 was affected. The pad, so the pad of the backlight feedback line was also affected. So what we had to do was basically to put a small we had to scrape the board for the line of PPHV underscore SOS W underscore OCD backlight. So we had to scrape a bit, and then we had to put a solder bulb there. And then also the backlight enable signal was also affected, and that was because R77 that was because also R7701 is that no R7731 was affected. So we replaced it, and in the process R7715 was knocked off of the board while we were replacing U7701, which is the backlight IC. And then so what we had to do was obviously we had to put it back, and we test again. We were before then we were having 8 point something volt on our backlight enable signal, which is way too high because we expected to have 2.8 volt. So we again tried retaining the previous U7701 backlight driver, and that didn't work. So what we had to do was to basically get another one. So we got another U7701, and that fixed the problem. Just some of the key points here: the enable signal has to be 2.8 volt, and then the feedback line has to U7701 has to be able to see what is happening in front of it, and that is possible through or through the feedback line at pin 5. If your feedback line is not if your feedback line is not healthy, the chip will not boost. If it doesn't boost, you will have 8.5 8.6 volt in place, and in that state you will obviously not have a working backlight. Your machine I mean the backlight output, it's gonna stay. I'm just gonna confirm something. So the backlight output, it's not gonna you will not have backlight at 8.5 volt. No, you need higher than that. I'm just gonna confirm something. So it said the backlight says that at that chip at max, that chip it's able to output a 50 volt. That is at max. But on your MacBook Air you do not get 50 volt. You may get 50 volt around about 40 something volt actually on the MacBook Pro, not on the MacBook Air. At so U7701 is able to go as far as to output 50 volt. But on a MacBook Air, you get around about 20 something to 30 something volt on a MacBook Air. So definitely on when you have 8 point something volt on your backlight, you definitely will not have, that's not going to light up your screen. So you need more than that, and that it's going to be made possible primarily with all of its required conditions, which is U7701. So the next thing we want to do is basically clean the board, and then as you guys know, we like to make sure our board is clean. So we clean the board, and then finally we do a bit of a test again just for you guys to see that our board is still working, and then we will have a finalized repair. And then Peter will take it up from there, assemble the machine, do all of the necessary testings, and then we will have a happy working machine, and then that will obviously lead to a happy client. So when you do this, just make sure that you do not leave flux all over the place. Nobody likes to open up a machine and then see flux all over the place. especially technicians, they don't like it. When the machine for any reason go anywhere someday for whatever it is, and the breaking our stream because of calls keep coming in. Okay, so we obviously just need to clean out the board so that we can finalize the repair. I usually really like to make sure my board is clean. I personally do not like to have flux all over the place on my board. And I know most technicians also do not like that, so they don't want to receive a board with flux all over the place. So just gonna wipe the board, and then the next thing I will do after wiping the board is to give it a test. Finally, just for you guys to see that indeed we still have a working backlight, and then Peter can take it up from there. So yeah, just wipe it real quick. Let's quickly s- just confirm. Okay. XW7720. So that's basically the where the feedback pin makes its way through to the other side of the board. Uh, so we did put a solder bulb there because that pad was broken and wasn't making its way to the other side of the board through that section of the board. So we obviously put a solder bulb there, and then that basically made the connections back. So that's and then like I said, if you don't have that, if that is not present, even if you replace 1000 E7701, you will not have backlight because you obviously will not have uh, your chip will not be able to tell what's happening in that section of the board. So just finally, let's quickly see what we have on our screen just to be sure that we have a working board, and then that will be it. And let's quickly just confirm that we still have a working board, and yeah, and then we can call this a day. Let's have a happy working machine for happy working client. Okay, let's wait for that beautiful Apple logo. Wait for it, wait for it, wait for it. That's it. That's our beautiful Apple logo. Thank you guys. I'll see you guys in the next one. Thank you.